Hello, my name is Dan Oak and I'm a student at Athabasca University, currently taking the course Computer Science 444 Embedded/Robotic Programming. If you've been following the videos I've been posting on the course forum so far, you'll know that I'm going through the SparkFun Inventor's Kit guide, showing you the projects I've created, including the coding challenges. So in a previous video series that I have up on the forum, I've went through Project 1, which consisted of 4 circuits, and in this video series I'm going through Project 2, and I've already had videos out there going through Project Circuit 2A, where it's mostly a buzzer, like a piezoelectric speaker, and then Circuit 2B, where we incorporate button presses and a buzzer to output different tones as you press the different buttons, as well as I've done the coding challenges for both of those circuits, with the last coding challenge incorporating an RGB LED with the button presses and the tones. So in today's video, we're going to be moving on to Circuit 2C, which highlighted in blue here is Circuit 2C is the Simon Says game. Basically, I'll explain to you how to incorporate multiple buttons to create an interactive game. The game is going to use buzzers and LEDs, and we're going to learn about reading inputs with digital read and using conditionals, if-else statements, to determine if the user's guess is correct or not. And then in the coding challenge, we're going to make a 2-player version of the game. I'll also be discussing coding best practices and that sort of thing. So we've already went through Circuit 2A and Circuit 2B. This is the notes that I have for those 2 circuits, just to help keep me on point. And this is the code challenge for Circuit 2C. But before we jump to that, let's go to the friendly guide here. So we just finished the coding challenge for Circuit 2B. Which is, again, was this. I haven't been mentioning the troubleshooting stuff, but basically, here's a couple quick troubleshooting tips. If the red board thinks that one key is always checked, well, you should just check the wiring. You might have the ground and 5 volt backwards, and therefore, if one or more of the buttons behaves weirdly, that like it's pressed all the time, that's probably what you have. Because if you've got it wired properly, the way our code would work is that we're using the internal pull-up resistors to pull the buttons high at 5 volts when they're not pressed, and low when they're pressed. So again, if you have anything behavior that's happening that seems different than what you're expecting, always start by checking the wiring. It's very easy to mix up the wiring, especially if you're old like me and your eyes aren't that great. If the buttons are not working, again, if you verify that you've declared your buttons as inputs. That is very important, obviously, that you've declared the buttons as inputs, because when you're pressing that, if they're not inputs, you won't be able to do the digital read on them, which is what you need to do to find out if the button is high or low, namely low, which means it's been pressed. And verify that you've enabled the internal pull-up resistors with input pull-up in the PID mode function. But anyway, we finished Circuit 2B. Now we're going to move on to Circuit 2C, Simon Says game. So the Simon Says game uses LEDs to flash a pattern, which the player must remember and then repeat using 4 buttons. This is a simple electronic game that's been a classic since the late 1970s, and now you can build your own. These are the components we're going to need: 4 LEDs, a potentiometer, a piezo buzzer, a lot of jumper wire, 16, and 4 push buttons. So the new concepts we're going to be learning today are the for loop. We're going to discuss the for loop, which repeats a section of code a set number of times using a counter, usually the letter I. Again, the difference between a for loop and a while loop is a while loop repeats some code until some condition is no longer true, whereas a for loop just iterates a specific number of times based on some condition. But you use a for loop when you know how many times you want to iterate through some code, and a while loop when you don't know how many times you want to iterate through some code, but you want to iterate through some code until something becomes true, or false for that matter. So here's the syntax for a for loop. You have the word for, and then within parenthesis you have 3 separate things. So you have you initialize some variable, in this case int I equals 0, and I is a common variable name for the integer variable that you're going to initialize in the for loop. And then you have a semicolon, and then you have some condition. In this case, we're verifying that as long as I is less than 5, as long as that's true, we'll execute the code in the for loop. And again, we know it starts at 0. And then we have our update, which in this case, I++. So what's going to happen is you're going to come in the first time into the for loop. You're going to initialize your variable. You're going to check the condition, so see if that variable is less than 5 in this case. If it is, you're going to execute the code that's between these curly braces. In this case, just serial.print I. We're just printing whatever I is to the serial monitor, so it'll be 0 the first time. And then, after we've executed that code, we're going to come back and call our update. In this case, we're going to update I by 1, and then we're going to check the condition again. We only do the init once. We're going to check the condition again. I is now 1. Is I less than 5? Yeah, it still is. We'll go into the loop, print it, come out and update again, check, and so forth. So this piece of code would iterate 5 times, from 0 up till when I is 4. But when I gets updated to 5, 5 is not less than 5, and we won't execute the loop. So the for loop takes 3 parameters, as just shown there. Measuring duration of time with milliseconds. I mentioned this a little bit before when I talked about button debouncing, but the breadboard has a built-in clock that keeps accurate time. You can use the millis command, which stands for milliseconds, to see how many milliseconds have passed since the breadboard has last been powered on. By storing the time when an event happens and then subtracting the current time, you can measure the number of milliseconds, and thus seconds, by dividing by 1,000, that have passed since that event took place. So this sketch uses this function to set a time limit for repeating the pattern. And again, this is a very common and popular technique used in button debouncing, but we haven't used it yet so far. Custom functions. We're also going to create some user-defined functions, and functions are essential to make more complex programs readable and compact. We basically are able to abstract away a lot of the details in convoluted code and just put them in a neat little function with an appropriate name and call that in our code. One, it abstracts a lot of details and a lot of lines of code away for us, but it also makes our code easier to read and understand what's happening. If we can just read a function that says, go to bed, well, I know what's happening in that function. This player is going to bed. Now that go to bed function might have a lot of things, a lot of sub-functions and code that's taken care of, like brushing teeth, using the washroom, having a midnight snack, reading a bedtime story, whatever. It might have all that stuff broken down, but I just need to call go to bed as a function. And that's probably a weird example, but let's move on. So the code, again, the schematic and circuit diagram is here. So basically our piezoelectric speaker is hooked in, as it has been this entire circuit, with the positive lead, denoted by this positive symbol, hooked up to pin 10 of the breadboard. Again, the speaker can be hooked up to any of the digital pins because we use the tone function with the speaker, and the tone function works on any digital pin. And then the negative lead of the speaker, instead of going directly to ground, it goes through the potentiometer, which ultimately goes to ground and connects to the ground of the microcontroller. And we're using the potentiometer as a volume control for the speaker. If we didn't have this and we had it just directly to ground, we would just have full volume all the time based on this digital pin. So this is acting as a variable resistor and allows us to limit the current going through the speaker. Then we have all of our buttons hooked up as usual. One of the terminals is connected to ground, and the other terminal is connected to one of the digital pins that will be set up as an input pin. And in this case, because we're not using any resistors in the hardware, like in the actual circuit associated with the buttons, because these resistors are with the LEDs, we're likely using the internal pull-up resistors associated with the microcontrollers. If we weren't using the internal pull-up resistors for the microcontrollers, then it would behoove us to have some resistors hooked up in the actual circuit here with the buttons. So again, we could pull the button state to a constant value, either high or low. High with a pull-up resistor or low with a pull-down resistor connected to ground. But either way, we don't want a floating value in the buttons. We've also got a appropriately colored LED associated with each of the buttons, so red with the red button, yellow with the yellow button, green with green, and blue with blue. And as always, we have a current limiting resistor, about 330 ohms it looks to be, with the hooked into our circuit with our LED. It doesn't matter if it's connected on the ground lead or the positive lead, as long as it's in the circuit. For these LEDs, they're all hooked onto the negative lead, which is the shorter leg with the flat edge, and they're hooked into ground. The positive lead of each LED is hooked into an appropriate digital pin, which will be set up as an output. And we can see, for simplicity, we have the red button and then the red LED, yellow button, yellow LED, green button, green LED, all hooked together. So that's how you hook that up. My circuit is not hooked up right now. I unhooked it for this last example to put in the RGB light. So I'm just going to disconnect my circuit, because whenever you're working on the circuit, you should have it disconnected. I'm going to take away this RGB LED setup that I have and throw that off to the side, and I'm going to re-hook up this button setup. So with this button setup, I'm going to hook up my, well, I guess I'm going to look at the code and find out what pins I have hooked up here. So I'll talk about the code in a second, but right now my buttons are on pins 5, 7, 9, and 12. Red button is button 0, so it'd be this one, 5, yellow button, green button, and blue. So red is on 5. It's kind of hard to see here, very low light in this room. So red is on 5. And then from there I can keep going. I can look at my circuit and just make sure that everything's correct. But I know I go, once I start going, it's just red, and then the other red one associated with the LED, right next to each other, just like the circuit diagram. And then the yellow pin associated with the button. Sorry, the yellow wire associated with the LED. Green wire associated with the green button. Green wire associated with the green LED. And I can verify right now that's on pin 11. And yeah, the green wire with the green LED should be on pin 11. Then the blue wire associated with the blue button. And then finally on digital pin 13, the blue wire associated with the blue LED, which makes sense. Blue LED should be digital pin 13. Blue LED. There you go. And don't forget to hook up, I can't forget to hook up my ground wire for my ground rail, where these are all connected, into ground of the Arduino here. Okay. And so first things first, I'll actually just upload the code. Always takes 4 tries to get this in the right way. So verify COM port 11, board name, and we'll just upload that code and wait a second, and then we'll talk about the code after that. I got it wrong. Anyway, that's code was successfully updated. Now let's actually talk about what the code is doing. So that's what their circuit looks like again, by the way. 4 buttons, 4 LEDs corresponding, the colors correspond with the buttons. Again, your potentiometer and your speaker. Here's the sequence of what the program does. We're going to check if a new game is started. If it is, we're going to play the start sequence and reset the counter that keeps track of the rounds. And then we're going to randomly generate a sequence of numbers from 0 to 3 that control the LEDs. Again, why 0 to 3 and not 1 to 4? Because we always start counting from 0 as computer scientists. So we're going to randomly generate a sequence of numbers from 0 to 3 that controls which LEDs the user will have to remember. The game works in rounds that progress from 0 to 10. Each round the game will flash LEDs in a pattern, and then the player has to recreate the pattern by pressing the buttons. that match the LEDs. In the first round, one LED will flash and the player will have to press one button. In the 8th round, 8 LEDs will flash and the player will have to press 8 buttons. A loop is used to flash LEDs from the sequence until you have flashed the number of LEDs that matches the round number, 1 for 1 round, 2 for 2 round, etc. So again, a loop is used to flash the LEDs from the sequence. We're going to start a timer and wait for the player to press a button. The player has 1.5 seconds to press the correct button. I might have to up that because that's pretty short for me, but if the time limit runs out before a button is pressed, the player loses. If the player presses the wrong button, the player loses. If the player presses the right button, we're going to move on to the next number in the sequence. And we're going to repeat this process until either the player has lost or correctly repeated the sequence for this round. If the player repeats the entire sequence for that round, we're going to increase the round number by 1. This will add 1 extra item to the end of the pattern. So if it was previously 3 LED flashes, it'll be 4, and so forth. And then we're going to go back to step 3 and keep repeating. We're going to keep incrementing the round until the player loses or finishes 10 rounds. If the player finishes 10 rounds, we're going to play the playing sequence. So we'll come back to this code in a minute, but we're going to go through this code hopefully a little quicker than normal because I know my videos are still getting quite long. Okay, so as usual, we have the multi-line comment explaining what the code does. The assignment says game flashes a pattern using LED lights, then the player must repeat the pattern. We've got all of our, I've just commented these two out. This is, we're using arrays for the buttons and the LEDs. I just commented that out because this is the buttons and LED pins associated with the example code that you got off of the SparkFun Inventors Kit website. I just changed it to the pins I could use because I had other things already hooked up to this Arduino and therefore had those pins used. So I just didn't want to erase it because if I start fresh, I'll probably just use those pins that were in the example. But anyway, the important thing here is that we're using arrays, one-dimensional int arrays for all of our button pins and all of our LED pins. As you get more and more buttons or more and more LEDs, like usually above 3, but you could even do it with 3 or 2 for that matter, it kind of makes sense to start using arrays to store your button pins and your LED pins. That way you can use a for loop or something to iterate through all of your buttons and all of your LEDs and either set them all up using pin mode or write them all high or low or do something. But basically by having arrays, having all your buttons and LEDs in arrays, it allows you to use for loops to iterate through them really quickly and do whatever you need to do. I also have an array for the various tones we're going to be using with these button pins. These are the 4 tones that I'll be playing. Each tone corresponds with one of the buttons and LEDs correspondingly. Couple of variables for int rounds to win, 10, and the button sequence. I'm creating an int one-dimensional array called button sequence, which will hold 16 different elements. So again, you could go up to 16 rounds, a sequence of 16 LED flashes as it's set up currently. Obviously, if you want more, change this value from 16 to some other number. We've got the buzzer pin as usual on pin 10, and then I've got a couple other variables. But press button is a variable to keep track and remember which button is being pressed. 4 is the value that will happen if no button is pressed. That's why I have it here by default. But if button 1 was pressed, 0 would indicate that, because again, we count from 0 as far as indexes go. We have a round counter starting from round 1. And these variables are associated with our time functionality. So we're going to have, and notice they're long, not int, because they're dealing with milliseconds, so it won't take them very long to get up to numbers larger than int will really satisfy. So we've got start time is a variable of type long, which equals 0. This is the time variable for the time limit on button presses, and time limit equals 2000. So start time and time limit. We're creating a Boolean variable. They use the word Boolean in the code. Again, Boolean is kind of allowed because it's kind of C++ Arduino derives from. I like Bool, and you can see it changes different colors, kind of what's typically used. I'll leave Boolean because again, this is what came with the code. But either or in this case will work. Typically though, one or the other would work. It depends on the language. You would have to have one or the other. In fact, even when we hover over it, it shows that it wants to be bool, right? So in fact, it may have to be bool in this case. It might be a little more finicky. So if you download the code and says Boolean, I would just change it to bool. You know it's going to work, and you'll know by this change in color. Variable to tell the game whether or not to play or start the sequence. So basically, yeah, this variable just tells the game whether or not to play the start sequence. It'll only play it when the game is reset, not at each round. In setup, we just set up all of our buttons as input pins using the internal pull-ups. And again, this is the beauty of the array. We can just go button sub 0, button sub 1, button sub 2, button sub 3, and set up all the buttons that way without using separate variable names. Although this could be done even better using a for loop, but we'll do that in the coding challenge. Same thing, I set up all the LEDs in the same way. LED sub 0, 1, 2, and 3 set all up as outputs. Buzzer pin set up as an output. And in the loop, we simply go if game started equals false, meaning if the game hasn't started yet, so if the game hasn't started yet, well then we're going to, if this is true, then we're going to come in and we're going to play the start sequence, which just flashes a start sequence. We're going to set the round counter back to 0, reset it. We're going to delay for just a second and a half, and then we're going to set game started to true, because now, after we've come through this code, the game has started, so we don't want the sequence playing again during the next round. So this basically just plays a start sequence once at the start of each game. Again, we don't need to put this code here. We can go game started equals false, but alternatively, we could have just as well done not game started, because game started is going to return is a Boolean variable, and it's going to either be true or false. Well, if it's false, then not false is true, and we'll get in here either way. So again, if it's false, which it is at the very start, because we set it that way, so when we first come in, it'll be false, not false is true, and we'll come in here. But then once we set it to true, meaning we don't want this to play the next round, well, not true is false, and we won't play here. So we could do that, but I'll put it back to the way it was. This is just this type of style right here, where you go equals false. It's just a little longer, but it doesn't really matter. And then each round, we're going to start by flashing out the sequence to be repeated. So we're using a for loop, for int I equals 0, as long as I is less than or equal to round counter. So we're going to iterate the number of times according to the round that we're on. So we're going to go through the array up to the current round number. And what are we going to do? Well, we're going to turn on the LED for that array position and play the sound. So we're going to call the flash LED method. It's a method we created. And we're going to pass in button sequence sub I. So remember, button sequence was that int array of size 16 that we had. And at the start, we're gonna see that we've randomly generated some button sequence, and we're now just pulling out the first element of that button sequence, whatever LED should turn on first. And we're gonna call the flash LED method, taking that in, and you probably guessed by the name, it's gonna flash that LED based on whatever LED it should be flashing based on this button sequence. We're gonna delay for a little bit of time, a fifth of a second, and then we're going to turn all LEDs off, calling this all LED off function, and delay again. Then we're going to go through the sequence one at a time and see if the user presses the correct button. So this is where we're actually checking that they're pressing the right button. So we're using a for loop, for int I equals 0, semicolon, as long as I is less than or equal to round counter, semicolon I plus plus. So we're using the for loop, going from 0 up to whatever round they happen to be on. And right away, when we get in here, we're going to call the millis function and assign it to start time, that variable we've created of type long. And what this does is it grabs the current time that since the Arduino or since your breadboard has been turned on, since your microcontroller has been turned on, and we grab that start time. And then we're going to go and do some stuff. We're going to go while game started equals true. Again, we could just take this out and it'd be while game started. If it's true, we'll exit the code. If it's not, we won't. We don't actually have to explicitly go equals true or false, but they've done it here, so that's fine. So while game started equals true, meaning we've already played the start sequence and we're just in a new round, we don't want to play the sequence again, we're going to do all the stuff in here. We're going to call a button check function. So every loop, we're going to check to see which button has been pressed and assign that to a variable called press button. So this button check function just returns whatever button happened to be pressed and then puts in this variable. If button pressed is less than 4, meaning it's actually one of the buttons, 0, 1, 2, or 3, meaning one of the 4 buttons, because remember, 4 is the value if no button's been pressed. So as long as it's less than 4, a button's been pressed. And then we're going to call the flash LED method, passing in the press button. So we're going to flash the LED associated with that button. And if button pressed equals button sequence sub I, so if the button matches the button in the sequence, which is, what we're trying to match, because that sequence is randomly generated, and that's ultimately the sequence of how the LEDs are going to flash by the end of the last round that we have to guess correctly in order. Well, if the button that we pressed matches the button sequence at sub I, so at the place that we're supposed to be at, then we're going to delay for a quarter of a second and then turn all the LEDs off and break, meaning we did good. Else, if it doesn't match, we're going to call the lose sequence function, which is some function we've created that just plays this losing sequence and makes you feel bad about yourself, and then we'll break. And if neither of these are true, if button press is less than 4, where we actually, meaning a button was pressed and we check this stuff to see if they pressed the right button or not, well, if it wasn't less than 4, meaning it was 4, no buttons were pressed, well, then we're just going to call the all LEDs off. We're just going to keep all the LEDs off or turn them off if they're on. And then finally, at the end of this, we're going to check to see if the time limit is up. So again, remember at the start when we first came into this function, we called the millis function to grab the current computer time since this program started, and we assigned it to start time. Now we're going to call this again, and this will give us the new updated time as of this second when we call this function, as of this millisecond for that matter. If millis minus start time, so if the current time that we just grabbed minus the start time, the time that we grabbed when we first came into this function, if that difference is greater than time limit, which is some variable we've decided on and created earlier in the code, up here we want 2000 as the time limit, i.e. 2000 milliseconds or 2 seconds. So if, where am I? Sorry for the jumping around. So if the current time minus the start time when we first jumped into this method, if that duration is greater than 2 seconds, which is what we have for the time limit, then the time limit's up and we're going to call the lose sequence. So meaning even if they haven't guessed wrong, per se, but they've just wasted too much time, then we call the lose sequence. Now, if game started equals true, again, we don't need this, we could just say if game started, and that'll be true or false, because it's a Boolean. But if game started equals true, we're going to go round counter equals round counter plus 1. We're going to increase the round number by 1, meaning if they actually have started the game, and now we've got past this point. So if we've got past this point, sorry, where am I? If we've got past this point, that means we haven't called the lose sequence or anything. We're doing all right. So we're going to increment round counter by 1. If round counter is greater than or equal to rounds to win, meaning if the round counter is greater than the rounds to win, well, it means you've gotten through all the rounds. So we're going to play the win sequence for you, and then just delay for a little time. Here's the functions we created. Flash LED. Well, we didn't create this. Was part of the regular code. Flash LED. Flash LED takes in a parameter of type int called LED number, and we simply do a digital write of LED sub that LED number. So we access the LED associated within the LED array we've created, and we write it high. We turn that LED high, and we call the tone function on the buzzer pin where our speaker is attached to, and call the tones LED passing an LED number. And again, what does that mean? Well, the tones array again has the same number of elements as both the button and LED array, so we're basically going to turn the LED on associated with the button that you pressed and also play the sound or the frequency associated with that button. And then turn off all the LEDs. We're just doing a digital write of all the LEDs low and turning the buzzer off using the no tone function. And here's the function that checks if a button, we check the button, which button was pressed. Button check takes in no parameters but returns an int. We're going to check if any buttons are now being pressed. If digital read of button sub 0 equals low, return 0. Else if button 1 is being pressed, return 1. If button 2 is being pressed, return 2. And if button 3 is being pressed, return 3. Else, if none of the buttons are being pressed, return 4. Remember, this will be the value for no button being pressed, 4. And then we've got our start sequence, and our win sequence, and our lose sequence. So, start sequence is simply, we're going to call the random seed function, and we're going to do a digital read of analog read on A0, which has nothing connected to it, but we're just going to do a random read of that. It'll return something, so that value might be floating to a point. But we don't really care what it returns, because all we're doing is using whatever value that returns between 0 and 1023, and we're using it to seed our random number. Because again, random number, if we call the random function by itself, it's not actually random. it's pseudo-random, so it actually has a complicated algorithm that's maybe too difficult for us to immediately know or be able to tell what number it'll generate, but it could generate the same number and over and over and over again if we just use the same parameters, pass in the same values. So we often want to seed a random number with something random, and by calling analog read on A0 and using that as the argument to our random seed function, we're going to make sure that the random numbers are really random. And then we're going to populate the button sequence array with random numbers from 0 to 3. Again, representing 0 to 3 represents the 4 LEDs. So we're using a for loop to go for int I equals 0 semicolon as long as I is less than or equal to rounds to win, however many rounds we have to win, I plus plus. So we're going to, however many rounds we need to win, well, we're going to have a sequence of LED flashes that's that long. So we go button sequence sub I equals, we call the round function, passing in as an argument the random function. So what's going to happen, first the random function is going to be called, and it's going to return a random number between 0 and 4, exclusive of 4, so it's really going to be 0 to 3.99999. But then we call the round function, turning it into an int, so now it's not any value from 0 to 3.9999, it's now 0 to 3, because we round. So we're going to get numbers either 0, 1, 2, or 3. And we assign that to our button sequence. Flash all of the LEDs when the game starts. We just use a for loop and go call the tone function, passing in the arguments buzzer pin, tone sub I, which is the first. Well, we're using a for loop, so we're ultimately going to play all 4 tones associated with the 4 buttons. But first it'll be the tone associated with button 0. We're going to play that for 200 milliseconds. Turn all the LEDs on, LED 0 through 3 in the array. All high, turn them on. Wait for 1/10 of a second. Turn them all low, wait 1/10 of a second. And we're going to do that 4 times. So playing 4 separate tones, each time turning all the LEDs on and off. The win sequence, it just turns everything high and then plays these noises. Play the 1-up noise. So play this frequency on buzzer pin for this long. So E6, wait a little bit, play G6, wait a little bit, E7, play a little bit, and so forth. And then we're going to wait until the button's pressed. So after we play the win sequence, we're going to wait there for the user to press the button and see if they want to play again. So we're going to use a do while loop, and do while loop works like a while loop, except it always happens at least once, whereas a while loop might never execute. But the do while loop will at least execute once. It'll at least come in here, and we'll call the button check function, again, seeing which button someone pressed, assign that to button pressed, and then we check the while condition after we do the code at least once. While button pressed is greater than 3, meaning while no button is pressed, we just have a semicolon here. We're just stuck in this endless loop. So until someone presses a button, we just stay here and do nothing. As soon as someone presses a button, this condition is no longer true, and we jump out of the while loop, delay for a little bit, and then we move on with the code. In this case, we reset the game so that the start sequence will play again. We go game start equals false. That way the next time we restart the game and the start sequence plays. The lose sequence is very similar. We turn all the lights on, but we just play different tones. Obviously loser tones, I guess. Tones that make you sad about yourself, I guess. And then we again do a do while loop, checking to see what button's pressed, and then we're checking to see if that button is, while that button is greater than 3, meaning while no button is actually pressed, we're just going to wait and hang out. As soon as it's pressed, we're going to move on and reset the game by setting game starter back to false. That's a lot of explanation. Let's just upload the code and move on from there. So I think we already did upload the code, but we'll do it again. And I'm going to have to go pick up my daughter from school shortly, so you guys are lucky. I won't be able to go through the code challenge, I don't think. Okay, I lost because I didn't do anything, but we'll do it again. I lost, so I'm going to press a button to restart. So I won. So it gives me that nice little sound. I press a button to indicate I want to play again. I do the tone. This time I screw up, and it gives me the no bueno. And then I can press another button to start again. It gives me a tone. If I waited too long past the 2 minutes, it screws up. So that's the original code that came with it. And now let's look at the coding challenge. We'll look at the coding challenge first, and then we can go through. We'll try to be really quick here. What did I do different in the coding challenge? I do have to leave in a few minutes, so I'll try to be quick. So right away, I have my Doxygen comments as usual. I included Arduino.h. This is included by default with the Arduino IDE. You only need to include it sometimes if you're using header files or things like that. I think I included it because originally I was using something with pitch. I was doing something with the Mario theme again and using a C++ header file, which is the pitch file. So sometimes you want to include that. I'm no longer doing that, so I could probably eliminate this and it'd be fine. In fact, I could eliminate this and be fine. But sometimes you have to explicitly do this if you're doing stuff with header files and other non-Arduino sort of files specifically. Or if you're actually using Arduino code but outside of the Arduino IDE, if you're using it on Eclipse or some other programming IDE. So that's why that's here. But I think I've since changed the code, so I don't really need that. I've got a bunch of constants for the number of buttons, which is 4, because I like constants, so I don't want to just have 4 buttons. I want the number of buttons to 4. Max rounds, 16. Rounds to win is 5. This is a 2-player version, by the way, the coding challenge. I'm just going really quick, because I do have to leave here momentarily. I've got a time limit of 2,000 milliseconds, 2 seconds. Buzzer pins on pin 10. Okay, so again, I've got button pin array just like they did with my 4 buttons, LED array, and tone frequencies. I've just made these things all constant because I know they're not changing, so I prefer to make them constant, which is why I've made the variable names uppercase, because they're not variable names, they're constant names. I've got a lot of other code. I'm kind of just going to talk about what's different about this in this 2-player version. If you really want to look at the code after, I'll probably either upload it or you can pause the video and look at it. But the main difference here is the fact that I've got 2 players. So for example, in the display sequence, I've got a variable where I call player turn and I assign it to a Boolean variable correct. And this is deciding what player's turn it is. So so let's just go to player turn right now actually. So player turn. This handles a player's turn to repeat the sequence. And it's true if the player successfully repeats the sequence, false otherwise. So if the particular player, the current player, successfully gets the sequence done, well then this will return true, otherwise it'll turn false. So how does it do that? Well, it uses a for loop to iterate from 0 up to the round counter, whatever round we happen to be on. Again, we call the millisecond function and assign that to start time, so we basically get a timestamp when we first start this function. We use a while true loop to come into the loop, and we call the button check function just like as before, assign it to this variable, indicates what button was pressed. If that button is less than num buttons, meaning if it's less than 4, which means an actual button was pressed, 1 is 0, 1, 2, or 3, one of the 4 buttons was pressed, because remember 4 indicates no button pressed. So if a button was actually pressed, we're going to call the flash LED method again, passing in press button, so we can flash the LED associated with the button that got pressed. If press button equals button sequence sub I, meaning if the button they pressed actually equals the LED in the sequence at the point in the sequence you're at, meaning you press the right button at the right time, then we're going to turn all the LEDs off and break out of this while loop because you pressed the correct button. Else, if it didn't match, then you got the wrong button and we're going to return false, in which case that's ultimately going to lead in the code in the loop to, no bueno for you, bad news. Maybe play you a loser tone or something. Now, after we pass this, either we broke out or return false, but we're going to go if, meaning if neither of these were true, meaning it's not that it equal or nothing, we just didn't press anything, meaning we never came into this code because we didn't press a button. Then we're going to go if millis, we're going to grab a new timestamp from the computer, by calling the millisecond. If millisecond minus start time, the time we grabbed when we first came in here, if that duration of time is greater than the time limit, meaning if 2 seconds have passed and you haven't pressed a button, and you were either right or wrong, but you just haven't pressed a button, you just sat there dumbfounded, then we're going to return false, which is still going to lead to loser tone. So either you get it wrong or you wait too long. Either way, you're wrong. And then when we jump out of this for loop, we are going to increase the round counter by 1, assuming that you didn't break out. Because again, the only way we return false and broke out of this function is if we were false. Otherwise, we just broke out of the loop. Understand that. So if we just broke out of the loop, we're going to increase the round counter by 1 because that means you get to go on because you did it all right. And now we return true. So again, the only way we break out of this function is either by returning false because you got the wrong guess, returning false because the time limit was up, or returning true because here we didn't return, we just broke out of the loop. Increase the counter and return true. So now back to where I called that. I called that here. So if you, on your turn, if you got the right thing, we assign it to this variable and we go if correct, we increment your scores. We increment scores at current player by 1. And that's just a variable that I probably went over. It's just an integer one-dimensional array with only 2 elements in it, representing the scores for players 1 and 2. If so I'd increment the score of that player, and if scores of the current player is greater than or equal to rounds to win, meaning, hey, their score now is enough to win, then we're going to play the win sequence for that current player. Else, we're going to switch players because they haven't won yet, so now we got to go to the other player. And this will switch players, and we'll go to that. By the way, if they weren't correct, we just play the lose sequence. But now let's go to the switch players function, because the main difference with this coding challenge that I did is I created the game for 2 players. And there's a lot more I want to do to this, but for now I just want to get the video out and get this done. So, this void switch player simply switches the player. My players, I'm using 0 or 1 for representing the players. So current player equals 1 minus current player. So if the current player was 0, 1 minus 0 is now 1. So basically I switch from current player 0 to 1. If current player was 1, well 1 minus 1 is 0. So I switch from 1 to 0. So do you see how this works? This code always allows me to alternate between 0 and 1, which alternates between players 1 and 2. 0 is player 1, 1 is player 2. That's weird, but that's computer science for you. We start from 0. And then I call this indicate player turn by calling and then passing in current player. And what does that do? Well, this indicates what player's turn it is. And so we take in a player, which is the current player 0 or 1, and we use a for loop to iterate through. Oh, that's time for me to get going here. Basically, I just turn on an LED. I use this tertiary statement again. I talked about this previously in this video, where if the player that got passed in here, if player equals 0, so if it's the first player, then I'm going to turn on the first LED using this array. The first LED high, otherwise low, and therefore if the player actually equals 1, meaning it's the second player, I'm going to turn the second LED on. So I'm going to turn a different LED on depending on who the player is. And then I'm going to output stuff to the screen. A lot of the other code's the same. So you know what? Without further ado, let's actually just upload this code. And I'll upload the code also on the forum if people are curious, so that way they can actually look through. So now it's player 2's turn. That's why that's so long. I left, and now player 2 has to do this. Now it's player 1's turn. This light coming on indicates player's 1, and I have it on for a long time so you can see. So player 1 has to do this. Now this one will be on for a little bit again, indicating player 2. And player 2, oh, and I got it wrong for player 2. So again, this light comes on for about 2 seconds or 5 seconds. I can't remember what I put it on. For player 2. I'm just going to show you that in the code. Yeah, so when I turn on the light, I leave it on for 2.5 seconds. But again, the red light is associated with player 1, the yellow light is associated with player 2. So let's see it again. So now it's player 2's turn. Started off with player 1, now it's player 2's turn. So player 2 has to do that. Now it's player 1's turn. That'll be on for 2.5 seconds. Now it's player 2's turn. Now it's going to be player 1's turn, and then I'll just let it die, and player 2 will win. So player 1 get it wrong, player 2 won. And if I would have had the serial monitor up, it would have actually showed whose turn it is on. Let me just pull this up. So I'm going to do a split screen here. So right now it's player 1's turn. And now it's player 2's turn. See? Now player 2 has to do something. They have to do that. Now it's going to be player 1's turn, so you see it switched to player 1. And player 1 has to do whatever. And now it's player 2's turn, indicated by the serial monitor. So if you can see, that's what's happening. I'm going to end this. I'm just going to unplug this. And so, quick note. Let's quickly... The code in the original code, basically, again, we used elapsed time. This is very important. This will come in handy in a lot of different code, especially with debouncing and stuff. The millis function returns the number of milliseconds that have passed since the red board was last turned on. Then Boolean variables. Boolean variables have only two values, 1 or 0, high or low, true or false, all that sort of thing. Helps save memory. Storing pin numbers in arrays. This is going to be really useful because then you can cycle through all of the LEDs or buttons connected to a project using a for loop. And I think I meant to show you that in my code as opposed to the code that they provided by SparkFun. In my code, I used for loops in setup to see. I used a for loop in setup to actually call pin mode and set up all of the buttons as inputs and all of the LEDs as outputs, because the I will just change as you go through the for loop. So really useful to do that sort of thing. Lots of code there. You can read that on your own. This was the coding challenge. Really, what I did for the coding challenge was did the two-player mode, head-to-head. And finally, let's just quickly go through the summary. The code challenge for Circuit 2, I just made two-player mode. You could read this on your own if you want to pause the video. But essentially, the big differences was I had code for handling the turns, so player turn, switch player, and indicate player turn. Future improvements, again, anytime you have a button, debouncing logic would really help. Again, using that millisecond function is a great way to do debouncing logic. I can do that in a separate video. Maybe add a separate RGB LED, I was thinking, in order to indicate what player it is, because sometimes it was confusing when it showed player 1 versus player 2 when the light came on, especially if that LED had previously been lit up in the sequence. So maybe a separate LED to indicate the player would be great. I wouldn't mind creating two separate button and LED consoles, like separate breadboard with 4 buttons and LEDs, so that two players could have their own thing and not have to pass it back and forth, which takes up some of the time. I also thought it'd be kind of cool to incorporate their own microcontroller with each of the LEDs, with each of the breadboard setups, and use the NRF24L01 RF modules to add wireless capability. I've shown those in previous videos, but basically so each person could be on the couch on opposite ends and playing the game together. Also, I think it'd be great to add an MP3 player module that plays recordings instead of tones sometimes. Maybe plays red, green, blue. Actually, the words red, green, blue. Maybe sings a song like "We Are the Champions" if you win, and I don't know, loser if you're, by Weezer if you're, a loser. I guess if you lose the game. I also think adding an LCD screen to display the message would be great, or an OLED screen or whatever. These are all the instructions. I did this up because my kids have actually played this a little bit. The system will indicate which turn it is using LED feedback. So the system will indicate whose turn it is using the LED feedback, which is that button, the LED turning on. Player 1's indicator is LED 1, player 2's indicator is LED 2. I have turn switching. The visual cue, the LED associated with the current player will blink to indicate whose turn it is. You might want to increase the 2-second. I found that a little hard. Again, I use visual and auditory feedback because your indicator LED blinks to signal your turn. Lots of different things. So again, long video. That was, but that's the final circuit for Project 2. So hopefully you enjoyed that. If you ran into any of these problems in troubleshooting, read the troubleshooting guides. Again, there's some good information here. If one of the buttons isn't working, it's often a wiring issue. Check to make sure one leg of the button is connected to the pin on the breadboard, like that you actually have it connected to the breadboard, especially if you're using separate breadboards like I do. Make sure you connect the ground rail on the breadboard as well to the to everything. Because, for example, if I have this all hooked in, I'll just do this quick. If I have all the buttons hooked up, but I've got the ground unhooked, it doesn't do anything. So if I've unhooked the ground wire, nothing's happening. So make sure that you're you're hooked up. What else? Yeah, if none of the buttons or LEDs are working, make sure you don't have the 5-volt and ground mixed up. The ground connection from the red board to the ground on the rail board. Anyway, again, thanks for watching, and I gotta go pick up my daughter. We'll talk to you later.